Well, welcome back to RDWorks Learning Lab. I'm still a bit obsessed with making copper mirrors because I do believe that they are going to be a very cheap option that most people could make for themselves, provided we get the method of manufacture correct. And I'm tackling the problem a slightly different way today. I have here a sheet of 1200 grit wet and dry, which I'm sticking down to a piece of 6mm Macrolon, which is nice and flat. But the main difference between this and the previous approach that I had was that I'm making all three together. Here I've got a piece of 1/2 inch thick steel. Now it doesn't have to be steel, it probably could be 1/2 inch plywood, for example, and it would probably work just as well. But what I've done, I've fixed my 3 mirrors with screws. If you remember, my mirrors have hank bushes on the back. So what I've got my washers there which are pulled back against this flat surface. Is add some water and some washing up soap, and we'll see how flat we can get these. Now I've been told that the ideal thing to do is to work these in a figure 8. And also to keep rotating them. Now this is quite heavy, so I'm not applying any load to it. All I'm really doing is just moving them around. Now I've got no idea how flat these are at the moment relative to each other. Well, I think the answer to that question is they're not bad, because they're nearly all, there's just little spots on there at the moment that have not cleaned up. But they're not bad for flatness. So it's not going to take very much effort to whittle these back to flat. Well, 2 out of the 3 look fairly flat. That one there looks as though it might require just a little bit round here. They're coming flat very quickly. Now I know that polishing with cloth is likely to round the edges, but as we're only interested in the central 10mm section, it won't really matter if the edges get a little bit rounded, but cloth will do a great job bringing the polish up quickly. Now what I'm going to try and do is to stretch the cloth on here and tuck it over you. Now here we've got our polish that we're going to use. It will naturally get spread around once we start working it. And again, I suppose for the purists we ought to use the figure 8 technique. Again, I'm just moving this plate around. The weight of the plate is quite heavy. I mean, it probably weighs, I don't know, 4 pounds. Just give it a wipe with the cloth to start with. I would say it needs a little bit more. Let's do it this way, shall we? Well, they're coming up pretty good. Now I can see when I look up at the twin lights in the ceiling there that they're not quite parallel all the way across. They do tend to curl off at the edges, but bear in mind, as I said, we're only going to be using about the middle 10 or 12mm of this, so it won't really matter if the edges are curled a bit. I'll just give it a little bit more polish. I mean, most people have an old pillowcase or a sheet, a thin cotton sheet that they can use to do this with. I'm trying to use manufacturing methods here that you could do in your own garage or workshop, or even on your own kitchen table. As I said, it's not essential to have this as a piece of steel. It helps because of the weight of it, but you know, it just means you've got to press down on it a bit more. But the whole principle of it is it keeps the mirrors flat relative to each other. Now, I was a little bit worried that if I didn't clean the polish off of this surface, it's got anti-corrosion protection in it as well. So it leaves some sort of surface film over the copper, which on the one hand will help to stop it tarnishing in the atmosphere, but on the other hand, potentially it could burn onto the surface and change the reflectivity of the surface. But it doesn't appear to be doing that at the moment, so I'm not going to clean it off. I'm going to leave it on there for 5 minutes worth of wet and dry, and for 5 minutes worth of polishing. They've come up extremely well. So it's taken 10 minutes to produce 3 mirrors, plus about another 15 or 20 minutes to make the mirrors. So, you know, if I've spent an hour in total making 3 mirrors, that seems like a pretty cheap set of mirrors. Let's go and find out how they work, should we? Because these, I think, are the best mirrors that I've produced. And there's my plate with counterboard holes in it to take the hank bushes. These are round hank bushes as opposed to hexagon ones. Well, we've got a few consistent results there, so I think we'll quickly change the lens. So if you remember before, in a previous session, I mentioned to you how dangerous this zinc selenide is. It's actually a very toxic material, and after I'd read the data sheet, you won't see me handling these lenses again without my cotton gloves on. Well, that's the new lens. It's an HQ lens. Now, whether or not it means it has any better surface reflectivity, I don't know, but we will just have a quick comparison with the lens that I'm going to take out. It almost looks as though that isn't coated at all, but having said that, when you hold it up to the light, when you catch the light across it, there is a bit of a surface coating on it. It looks a little bit misty and cloudy on that surface there. Zinc selenide only transmits in its raw state without any protective coating on it. It only transmits about 70%, the other 30% is reflected, which is why we go for coated lenses, because that coating can actually raise the transmissivity of this lens to as high as about 99.5% or better. So I'm very hopeful that I'm going to get probably another 2 or 3 watts out of this head now. So we just make sure we put this in the right way, which is convex side away from the work. So that's about 34.2. So if we take a look at those results there, we see typically we're in the, well, if we're kind about this and we say we are nominally 32. And if we look at these results here, well, they started off low, but they seem to have settled down quite a lot higher. Judgment call, what should we say, 34? Now 2 watts doesn't seem a lot, but when you consider I was getting, typically I was calculating 8 to 10% loss through the lens. So if we started off with about 33 watts before the lens, then we'd finish up with about 30 watts after the lens with a 10% loss. So it means we were losing 3 watts through the lens. Now it would appear that we're only losing 1 watt through the lens, which is a significant gain. So now what we should do is work our way back through the system. We'll put my new set of copper mirrors in to see whether we can wring any extra watts out of the performance of this machine. Well, I'm now going to upset my mirrors and change the mirrors, so it means I shall have to take them out and physically upset all the settings. But before I do that, what I'm going to do is to set up my pointer so that we don't have to go back and reset everything. I should be able to just use this as a reference. Right, before I upset any of my settings, I'm going to put the laser right at the front of its stroke where I can get to these screws here, and I'm going to do a little pulse test just here. I might need to tweak that at a later stage, but that's where the laser is pointing at this very moment in time. So now what I'm going to do is turn the machine off, or turn the laser off. So the laser is now turned off and safe. Right, so there's the pointer on there. Just fiddling with these two screws. Take it down and show you there. So mirror number 1 goes in there. And now that I've done them back up again, all I've got to do is just gently tweak that top screw to bring the mirror down a shade, and there we go, back on target. It's as simple as that. Now I'll go and replace the mirror at the back. A quick run round the light path tells me that we've got 40 watts coming out of the laser. We've got 38.3 after the first mirror, 37.2 after the second mirror, and then we get this massive drop at about 3.4 watts just through that one mirror, whereas in fact I got less than 3 watts across the previous 2 mirrors. So we've definitely got to look at this particular mirror here, and what I'll do, I'll swap this mirror over for the mirror that I took out the back corner. And we put our number 1 mirror in from the previous batch of mirrors. Well, that's not a lot different at 34. It's really weird. It's not the first time I've come across the problem that this mirror here, whatever I do to it, seems to be losing more than any of the other mirrors. Because the laser beam is turning through 90 degrees here, it's in a different plane. It shouldn't make any difference as far as I can see. Well, I'm really puzzled about that, why I'm losing so much just there. So what I'm going to do is to rip this head off and have a look down that tube to see if there's anything sticking out or in the way. I think I need to just do a bit of a drawing of that head and see where the centre of that mirror is in relation to the centre of this hole, because maybe that's where I'm going wrong. But there always seems to be a problem with that mirror, and the only thing I can think of is that somehow the beam is clipping the mirror and not transmitting all the power downwards, because I've noticed it before that this is the mirror that's causing the problem. Well, you see that little insight there has all of a sudden thrown up quite a major problem and a solution, because when I draw this out and look at the measurements of it, to get the laser beam going down the centre of this tube, the mirror is in about the right place, give or take a millimetre. So that's not the problem, but it's this entry hole. Look where the mirror is in relation to this entry hole. I've been setting the mirror here on centerline, and it's at least 3.5 millimeters too low, which probably means I'm clipping the edge of this mirror here. So I'm going to mark my head out and reset my head so that the beam goes in at 43.4, give or take a little bit. I'd like the purists to look away, because this is not the way to treat a vernier, to use it as a scriber. But this was only £12, so hey, I've got them in my workshop. I've got several of them in my workshop, and I just use them like this. So there's a line there. Look where I've had to mark that line. That's where my beam has got to be. So that's the beam at its extreme point. Let's see where it hits. There we go. We can see where it's hitting. It's a good, yeah, 3.5 millimeters low. Your first reaction would be to jump to mirror number 2, which is back there at the other end of this axis, and adjust the beam up slightly. Wrong. The beam is already set along here, both parallel in that direction and in this direction. So all I've got left to do is to adjust this head up and down. And now all of a sudden we can see the reason why I've got these adjustments here. It's going to be very easy for me just to undo those screws and drop that down by 3 millimeters. Just nip that up very lightly, because I need to check the squareness of this face as well. Now I'd normally do that adjustment with my red dot pointer, but it's such a simple adjustment I'm not even going to bother. So let's just quickly blip that again. And you can see now I'm slightly high, and I think we're probably on centre, but let's check it. That looks pretty good. Maybe slightly over to one side, but we can set that in a second. Right, well I need to just slightly move that head out. By a very small amount. Let's try that, check for squareness. And we'll see whether we fixed the problem that I didn't know I had. I think anybody with this design of head would not have identified a problem there unless they had a power meter. And even with my power meter, I didn't really identify the problem until I'm looking for such small amounts that I didn't know that I'd lost 2 or 3 watts there, probably because the beam is clipping the mirror. So that's now 1.5 millimeters parallel and 45 degrees. Now that's a good nominal starting point for getting the beam to go down the centre there. Well, we're running a set of results now that are done one after the other, because this machine has got a tendency to perform rather erratically over time. I mean, earlier today we were seeing 40 watts out the tube. Now I'm seeing 36.8, 37. It might even be 35.6, but we'll give it the benefit of the doubt. And now the moment of truth. Nearly. Because we've still got to go put the lens in now. 33.1. I'll just carry out that test one more time. It just made 34. I think you can probably see down the inside there that that's shiny. That's because I've already drilled this out to as big as I can get it, to about 15 millimeters or something like that, 14 millimeters, to try and make sure that there's no way that the beam hits the tube as it passes down the middle there. Now they look a pretty impressive set of figures. Not necessarily as far as power is concerned, although it looks as though I'm at least 4 watts more than I was expecting to get out of this machine. I've always considered this to be a 30 watt machine at the working face. Now I've got another 4 watts. Wow. Let's go and have a look to see what and where we've gained. Now I can see here 35.5, 1.5. That's quite a big drop there. But if you remember, I swapped my new mirror for my old mirror. So perhaps before we disappear, we ought to just go and put my old mirror, take my old mirror out and put my new mirror in. The new mirror is now giving me 35.1. Yep, that was a good result. Wow, that did just about make it up to 34. So we will just check that one more time. Yeah, just about made it up to 34 again, so we've got to accept that result. Let's go away and take a quick look at the results and see what they actually mean now with my new set of mirrors and my new HQ lens in. A few weeks ago I had a machine which was delivering 38 watts at the tube, and I was lucky if I got 30 watts down at the cutting face. And the first block of figures here represents typically what my machine was a few weeks ago. I was absolutely staggered when I used my power meter in various parts of the machine to find this information out. I'm losing 25% of the available power through the light path. Not acceptable. Must be able to improve that somehow. Hence my search for better mirrors, better lenses. I already knew of the very high reflectivity of copper, but I never imagined I'd be able to make my own copper mirrors. But when I did a little bit of research and found that industrial mirrors are available, but they're about £40–45 each, I thought, no way, I'm going to have to go and look in my workshop and see what I've got. The copper that we get commercially, a grade called C101, various countries have got different gradings for it, but it's 99.9% pure copper. It's used electrically and architecturally all over the place. And if you go onto eBay, you'll be able to find little scrap offcuts of copper plate. 2mm thick, 1.5mm thick, either will do the job. You can make your own mirrors very easily. So being the resourceful person that I am, why spend money when I can have a go at making them myself? I get the pleasure out of trying to solve the problem, and I could finish up with an expensive mirror for free. Now if you look at the bottom block of figures there, you'll see the target values that I set myself a few weeks ago. We were looking for something like about something under 3 watts worth of loss would be typically what you'd expect from a commercial type of machine. You would be losing something like 2% through each mirror and 1% through the lens. And for my 38 watt machine, that would be equivalent to losing about 2.5 watts. Now obviously the one thing that I can't do anything about is the lens. It's a very special material and it needs a very special coating. Now I bought an HQ lens which was more expensive and better than, I hope better than, a standard lens, but it's still not a commercially high grade lens with a triple coating on it where the transmission can get up as high as about 99.5%. And there are new figures for telling me what transmission I'm going to get through an HQ lens. So it was very much an act of faith when I bought an HQ lens, assuming that it would be better than the standard lens that I had in the machine. Well, it did turn out to be that way, as you can see, because after several weeks worth of work and a lot of learning and understanding about the light path on the machine, I think we could say that we've more or less achieved the target that we set out on. Because look, out of 37 watts, I've got a 2.8 watt loss, which I think you would agree is pretty damn close to the target values. So when we look at my mirrors, we'll see that we've got 98%, 99%, 99%. I mean, these are phenomenal free mirrors. And I think you can see the benefit of the HQ lens, because that was really, in its own way, one of the biggest losses. So we've decreased that loss from 10% down to 3%. And at the end of the day, I've potentially got another 4, 5, maybe on a good day, 6 watts of power available to me. Somebody joked that I was trying to wring every milliwatt out of this machine. Well, they weren't far wrong. It was for no other reason than the challenge. And I think that challenge has now been met, and I hope that you have learnt something from this as well. The power meter has been an absolute invaluable asset in trying to track these problems down. Without it, I would have not known I had a problem, and I certainly wouldn't have been able to quantify the problem and improve it.